Welcome to Commit and Push, the podcast about how great software really gets built. I'm Damien Filiatrault, your host and the founder of Scalable Path. Each episode, I talk with founders, developers, and leaders about the decisions, trade-offs, and hard lessons behind successful digital products. Let's get into it. Today I'm speaking with Justin Gelinas, Chief Business Officer at TAHO Labs, which is a startup building low-level software that allows companies to get the most out of their existing infrastructure resources. Justin, welcome.
Thanks for having me.
Yeah, I love your studio there. I have envy about your background. I'm always kind of self-conscious of my simple, black, cold background, and I hope to have such a cool little backyard. Is that technically an ADU?
It is technically an ADU. It's about, 350 square feet, and it serves as like a recording studio and an office space. And I nerd out in here all day.
Yeah, I'm jealous. Looks awesome.
Yeah.
So I definitely want to get into TAHO and the product and the tech, but you've got a particularly interesting background, from having studied visual arts and even producing music. So can you share a bit about your background and how you ultimately got into, tech from your other non-tech background?
Sure. I think I've been a maker my whole life. I also think back, and I've also been a little bit rebellious at my core, which has been hard for me to work for other people, I think. So I've kind of spun out and worked for myself for the last close to 20 years now. But I've worked alongside some amazingly brilliant technologists, data scientists, producers. I've had a real switchback career where I've worked on things from the Grammys and Super Bowl to Davos World Economic Forum, doing really big IoT smart city build out projects. And now we're building really deep infrastructure, really rooted around creating efficiency at scale for AI and energy. But it all really stems from my curiosity as a maker and trying to create things that never existed before. And I can reflect back, from the earliest days of my childhood memories where I would just be obsessed with drawing. I would look at blank canvases or blank pieces of paper with such imagination, and that was like my most magical memories as a kid, was creating stuff that would somehow then live on after the fact that I would make it.
Yeah, I can totally identify with that. I think a lot of us, in my world as a software developer, that's just our way of being makers, and it's funny, like you look at developers and what they want, what motivates them to come to work every day. It's building something cool and new. That's probably why a lot of developers hate doing the other stuff, like writing tests for their code, because that's not the fun building part. But I thought an interesting place we could start would be talking about Wirth's law. I read that blog article on the TAHO Labs website, and I'm actually interested in it from a slightly different perspective. But can you talk about that a little bit? What is Wirth's law, and how does it apply to TAHO?
Yeah, well, my colleague Morgan Gebhardt, who's our CRO, he wrote the article, and the thesis around it from Nicholas Wirth states that software is getting slower and more rapidly than hardware becomes faster. But by opening up and unlocking efficiency gains, that you actually start to spike demand at a rate that you might not have been assuming. And we're looking at this and reflecting on this through TAHO, because today the problem area that we're focusing on and we're really obsessed with tackling is the inefficiency layers and the untapped potential that lives within compute today. And that's really the thesis around the company that we're building, is to open up efficiency that we've been told doesn't exist, but we've looked and we've found lots of different ways for reducing waste that will create more upside and more productivity.
Yeah. I mean, the concept of the idea that when you make something more efficient, that you're trying to reduce the consumption of this. I think there was an example in the article about coal, like when locomotives became more efficient, they thought that that would lead to the less use of coal, but then it actually just made people build more locomotives, and it made train travel like more economical and more attractive. So coal actually, the pollution and the use of that resource went even higher. And so same thing we're seeing in, you know, with compute, if it makes it, if you can do, X amount of computation for half the energy, then maybe doing computation becomes cheaper and people want to compute more stuff. And it all relies, it doesn't work for every industry, but for industries or, businesses with a very elastic demand, that I've had another conversation where they talk about this, where there's just deep demand that doesn't have like a limit, then this happens. And it's definitely happening with AI compute needs right now. And I'm curious about it too, because with my business I'm in the software development business, and it's all kind of related in that, with, software developers becoming more efficient and more productive with the use of AI, one of the things a lot of software developers, and we're kind of seeing it, there's a lot of layoffs. People are wondering, like, are people not going to be hiring as many software developers because they can do more with less? And I'm kind of optimistic that what's going to happen is that, there's an elastic demand that, if one developer can, using AI agents, develop twice the software, that's just going to cut the cost of building software in half, and there's going to be more demand for projects because something that cost 100,000 might cost 50K now, and you're like, well, I would do it for that. So, I thought it was an interesting.
Yeah. No, I agree with that. And when I see that play out, I mean, my observation, just to add on to it, um, we're seeing lots of layoffs. We've seen lots of mass layoffs. Um, is it because AI is adding additional value and capabilities? Yeah, it's difficult to measure it today, though. Um, my personal belief is that a lot of those layoffs that have happened is more of a fiscal rationale, because the costs for running this intelligence at the scale and at the velocity that these companies, these enterprises, I think that they've gotten over their skis so hard, and the costs have been climbing so darn fast. I mean, Uber famously spent their entire AI budget of 26 in the first 3.5 months of this year, as an example, right? And I think that the layoffs are a little bit of an overreaction for CFOs and boards as a means of trying to protect margin. I do think it's really important for engineers to be in the loop on these things. I think that we're finding out how important it is. But I do think that what you're saying and what the article is, essentially supports is we're going to get more output. It's going to allow for people to deliver at a fraction of the cost. There's going to be more value. I'm just personally not a doomer in the fact that, like, I think that there's going to be a lot of opportunities for software engineers into the future. I can say indefinitely, like with the stuff that we're building, we've attempted to use AI
Mm-hmm.
for some of the really difficult things, and we can't do it. And partially the reason that we can't do it is we're building things that never existed. So if you're wanting to do that, AI is naturally built on data sets, and if it has no
Mm-hmm.
data to support new things, like, you're going to hit a brick wall pretty quick. But in addition, the amount of slop and technical debt that gets put in if you are just like, if you don't have people really observing closely, and that can be really counterproductive as well.
Yeah. I mean, that was one of the questions on my list here was like, how much are you guys using AI to build Tahoe?
Not nearly as much as you would think. I mean, we use it all the time internally for our
Yeah.
ops and systems and, doc creations and just like more operational stuff. But when it comes to actually writing the code, we're not using it as much. And it's because of the fact that our software is comprised of 6 inventions essentially, and each one of them, there's no blueprint for how to do it because we're taking really abstract means of generating these new techniques. We've tried and we've failed, and on the good note for us, like it gives us a little bit of a moat, because there's a time that people are going to have to, we've been building, Damien, for more than 2 years, like in a stealth mode labs type environment. So yeah, it's been interesting to see everything really evolve in the last 2.5 years, like what's happened in the marketplace, the way that engineers, are in the market today. It's quite a wild ride, to be honest.
Yeah. So a quick pause here. I wanted to tell you a bit about why I started my software staffing company, Scalable Path. Back in 2008, I was working on a client project with some developers in Argentina, and I saw how amazing it was working with people in my time zone who were just as available as people in my office. So in 2010, I started Scalable Path to help companies take advantage of this underutilized talent pool. And since then, we've built a platform of over 40,000 developers, and we've placed over 600 of them with over 300 clients. So if you're looking to hire top-notch dev talent at a fraction of the cost of hiring locally, visit scalablepath.com/commit. And as a listener of the podcast, you can get 20% off your first month. I'd love for you to give us a try. Well, so you can't tell me about that you've got 6 inventions inside your software and have me not ask about that. Can you talk about those?
I can't because of IP. Honestly, like, there's I would get into some hot water quick if I start to divulge the details of what they are. But basically,
are you guys like patents pending on these things? Yeah. Okay.
Yeah, we are. And I'll just break it down in a really layman terms as to what we're doing here.
Yeah.
So, okay. We were just hanging out with Jensen a couple months back at GTC for a private event. And ever since then, he's been amplifying this same message, both in educating and selling the market as to how do we conceptually think about the industry of AI. And he's broken this down into 5 distinctive layers. At the base layer, we've got energy, power and cooling, right? We can't do anything in the world without that primarily, right? So that's kind of base layer number 1. Above the chips layer, we've got silicon and that supporting control plane and chain. Layer 3, we've got infrastructure, and there's a lot of things nested into the infrastructure layer, as you are quite familiar with. And then above that, we've got layer 4 that he describes as the models. So in general intelligence, mixture of experts, LLMs, diffusion models, et cetera. And then above that, you've got applications. And that could be anything from Lovable to Adobe to Gemini, Claude, and ChatGPT, right? So you've got this ecosystem in the way that he's framed it. I reference all of this because where we live is in an interesting place, which is at the base of the infrastructure and right above the silicon. And what we're doing from an invention perspective and what our product just does inherently, within the infrastructure layer, we're bound by really old software techniques that in many cases go back to 2003, 2004. And when you think about the world that existed in 2003, 2004, we were not building software to support the future where AI lives today, where the workloads are 100 times more dense than they were just a couple of years ago. So today, the way that AI jobs and workloads land. They land within a processor, and then it breaks apart the job within the processor, and then basically kicks it out. What
Can,
we're
can I ask you one question? Because this is on my list, and I don't want to derail you. But like when you say a workload, do you mean some like big thing like a training run or something that's for like AI developers that are working on models, and or are you talking about even just you send a prompt to a model and that model that prompt needs to be processed and tokens need to be you know used and a response needs to be given back to the user.
Yeah, so with respect to Tahoe, the style of workload doesn't necessarily matter. We're focused on inference a lot today for our customers because that's where a lot of the direct pain and the costs are. But what we do fundamentally is we take that workload and we break it apart into many thousands of tiny, tiny jobs. And when we break them down into those jobs, we can distribute those tiny jobs across your entire technical fleet. And it allows your CPU, your GPUs across your stack to run more saturated, much more efficient. And then it reduces the idle time and the waste that's technically happening when you're landing a much bigger job within a processor, and it takes time to cold start, it takes time to basically digest it, evaluate the many billions of parameters before ultimately kicking it back out for you. And that's what the inventions that we've been developing really do. It's that technique, and then also it allows us to run our software in a heterogeneous manner, meaning we can run across NVIDIA and AMD and Qualcomm together, and that's a pretty big breakthrough
Yeah.
as well.
And I'm glad you shared that because that is from all I've read about your software, that is the core thing, that splitting of workloads into smaller units. But I don't know that I got my question fully answered. Like, is this like let me ask in a different way. Like,
Sure.
who's your client? Is your client that that buys Tahoe, is that a company that's training LLMs? Is that a data center? Or is it a company like, or is it a broader client base that's like you know has a large web application that or just using running llama and like on their own self-hosting a model and then handling a lot of prompt requests, like who.
Yeah, so it's not to say that we can't support data centers, but of the people that you just referenced, we're building this for a kind of B2B enterprise, and our ideal customers are companies that are spending, the top 300 customers of that Fortune 500 that are spending 100 million and up in compute every year. Those are the ones that are feeling tremendous amount of pain. It's also many of the companies that are doing the biggest layoffs. Again, why the thesis is rooted in layoffs associated with financial pain, as opposed to these engineers no longer serve the same value that we thought that they once had. So where can we offer? So the other interesting thing. So you referenced people that are running open weighted models, and maybe they're doing that within the confines of their own data center, as an example. We can support customers that do that as well. We live behind the firewall of our customers. We're really early days, Damien. So, the rest of this year and into next year, we're really starting our go-to-market motion right now. Currently, we're working with a really big bio tech company. We're going to be helping them with protein folding. We're working with their research division and assisting them in their labs, both in inference and training. So to kind of cover that question. But then the other thing that we're doing is with a large social media company right now. And, the biotech example really talks about that type of compute at scale. I mean, this is a $30 billion plus, revenue business. They're spending a ton of money in compute every year, and that's drastically growing. And it's a mixture of open weighted model and closed models. And then on the flip side, we're working with like social companies that are doing interesting things with edge devices and running really large models on board of small edge devices. And because of the way that our product lands, we can expand the capabilities of that limited hardware by taking advantage of other devices that are connected to the network, and kind of giving it additional intelligence in a way. Does that answer the question? Give you a little bit more visibility?
Yeah, I mean, it sounds like your early days on like exactly you know who's going to use it the most, or where it even fits the best. You just know that you've unlocked you've got a way to use the resources more efficiently, and how that gets applied is not really clear. My audience of people is like software developers, and probably most of us are um operating at a higher level in the stack. We're writing in Python and you know TypeScript, and we're building applications, and we're using LLMs a lot. It's a smaller group that are actually doing like huge training runs,
Yeah.
and I'm just wondering if like how much this product is going to. It sounds like it's a pretty niche product, right? And it's for companies that are doing large workloads, um, and it's not so much like. Do you ever think it's going to be a mainstream product like that will be, um, you know, you mentioned that it sits right on the silicon. When I was reading about your product and your docs, it seems like it. I mean, how does it relate to the operating system? It seems like it kind of runs on the operating system as well. But like, is it just above the OS kind of? It runs on Linux and Mac OS.
That's right. Yeah, it's like basically lives right above the silicon, and because we're breaking things down at the thread level, it's breaking it down into like assembly layer, code, right? So it lives at the end of your workloads as far as like when you're running those jobs, and because it lives there, that's where we're getting a lot of the efficiency down at the core level, which then get distributed to the hardware. Um, I will back out and say your audience is probably more technical than my personal background. I'm on the
Mm-hmm.
business side of
Mm-hmm.
things, and I've been on the business side for several technology, like deep technology companies, but I'm not an engineer by trade.
Mm-hmm.
So, as far as like, you know, the user level experience, either my CTO or CEO that are engineers,
Mm-hmm.
they would be able to dive a lot deeper into. But to answer your question though, Damien, like we do see ourselves as defining a new primitive for this. We think that we've got something that's going to be beneficial for every category of customer, whether it's small business or enterprise. We do see this being a massive unlock for efficiency and cost savings for customers, whether you're renting space in the cloud or you're building out your own small or large data center. Um, and we kind of think about this as, in a future state, similar to like Visa or MasterCard, which are just, they make very small amounts of money on many, many transactions. Um, if we can return 10x ROI for running workloads, again, regardless of the size of the business, we see there being a lot of value there because we're watching the cost climb for our customers, and the inherent pain that both people on the engineering side as leaders and also on the business side are scratching their head and saying, this doesn't compute, this doesn't scale. Like the financial pieces here are, making us like forcing us to make really painful decisions. So yeah, that's
Yeah. Yeah, I think we kind of skipped over some of the really compelling reasons why you guys are doing what you're doing. Like
yeah,
I was totally drinking the Kool-Aid on the blog about, how only the average utilization of was it just GPUs is like 5%? Was that specifically to GPUs, or was it, I
right.
don't know, all compute?
Yeah, yeah,
But
like yeah, the clusters. It's crazy. Even the most wildly successful studies that were published by, I think that it was Meta maybe, and then also NVIDIA, publishing their own data points. I think it was between 43 and 47%, but the vast majority of customer data that's been published, I think it was IDC that published the article, and again, really credible resources that we were finding was between like 5 and 15%. So if you think about it's such an expensive asset that you're either renting or buying. And if you're only getting, 15 cents of value for every dollar that you spend because of the inefficiencies and waste that's locked in to the stack, it's a staggering number.
but
Yeah.
how much of that number is because they're just like not giving it a workload most of the time, and it's not really how efficient the workload is operating when it's running?
You know, I don't know all of the deep data on that front, but what I believe that it is that there's parts of a processor when a workload goes to it, there's many parts that are just sitting there, not being used, and it's waiting to be used, and there's inherent waste within idle time, and the aggregate of that is the percentage that is being referenced as waste in the article.
Like, how are you guys building this product? Do you know? Can you share like what programming languages you guys are using, and anything from your team about like some of the challenges that you've encountered in building really low level software that sits so close to the OS and the silicon?
Yeah, I'm not going to be able to go super deep, but I can answer the question to the best of my ability. We're writing in Rust.
Okay.
I do know that we're building adapters for our customers so they can actually use it in whatever language that they want, but ultimately it does layer down into Rust. Some of the difficulties that we've run into, I know at one point we had to do a really large refactor because of the Onyx runtime. At the time that we were using it, we thought that it was really well supported, and that because it was backed with
What? Fill me in. What is the Onyx runtime?
Onyx is a runtime that was offshoot from Microsoft, I believe, and it was a part of our build that we thought was going to. This is where I'm going to get a little fuzzy, and I don't know whether I'm going to do it quite justice. But I will say this: there have been several places that we have assumed we're at the top of the mountain, and we realize that there's more mountains to climb. At almost every stage of the 6 inventions that I referenced, we've kind of caught wind with bogeys that we were not anticipating. We've encountered it with runtime issues. We most recently shifted to MLIR, which I believe is an Apple-based runtime that also works with Linux. And we've had to refactor our code in pretty big tranches on a number of occasions based on unforeseen challenges that we couldn't have anticipated. But I'll say this, like, in my experience, because I've had companies and I've been part of teams that has built things that haven't been done before. It's part of the process that comes with it.
Mm-hmm.
Um,
Yeah, it's
it's
kind
not
of
a
exciting. It's a
it
challenge.
is it's a challenge and it's exciting and someday and the highs and lows are really big.
Yeah,
Because
yeah,
there's lots of things that you couldn't have anticipated along the way. But when you get to the top of the mountain, before you have to climb the next one, you can give each other high fives because you can kind of see,
yeah.
the where you've come from.
I mean, how far along do you think you are? Like how mature is the product? Like, are you still at a point where you're like, are you at the point like we've solved this, like we have something and we've solved it and it's valuable and now it's just we need to like package it up and go to market? Or are you still, you know, working on getting to the top of the mountain, and are there still some like challenges that you're working on sorting out?
We have something that's really compelling today. We're about to raise some more cash and start our go-to-market push and build out our engineering team. We're a small team today, of just 12 people, um, many of which come from, with a great pedigree of background experience in engineering and big enterprise environments and, aerospace. And we're looking to bring on more production engineers. For the next year, we're looking to land in a total of 10 customer environments. Each customer would be a leader in a particular vertical. So we've targeted 7 verticals we're going after. And we're looking at these as design partners that we can go really deep with over the course of the next 18 months, roughly, that takes us into the end of 27. But we've got something really compelling that we think has tremendous value. And now it's about finding those right partners to really lock arms
Mm-hmm.
with, tighten the product, and to get to a GA product where, maybe Q2 customers that are maybe in smaller categories, they can download us with the proper documentation. They can get it up and running by putting the binary on the machines that they want it to run and expand, the execution fabric for where they're running their work and allow them to be off and running without the same level of support that we'd be giving early day customers.
Yeah. For when you say GA, do you mean like generally available? Is that what you mean?
Yeah.
Okay. And I don't know. I'm curious, like, how do you structure these, initial engagements? Are they like the clients just sort of cover the cost of you doing custom work for them to get them integrated into their environment? They get sort of a discount a little bit, but for being a first customer and working with you, is that kind of how you structure it?
Yeah. So today, it would be discounted license agreement, right? And depending on whether they would sign up for 1 or more years, there's different rates that we could apply. Um, Additional, opportunities is like a per node basis. So for a customer that's running 20,000 nodes versus 50, or if they want to test us out in maybe 5,000 nodes, right? There's a spectrum there, in which we would kind of build a contract around. Into the future, we see this being a consumption-based modeling. So similar to how you're renting GPUs in the cloud today, and you're
Mm-hmm.
only charged and billed with what you actually use. That would be the way into the future, that we'll be billing customers most likely. But today, what we're looking for in design partners is giving people screaming deals, locking arms, where they get access to our engineers, and we build um, to their specific workloads that they're running, and whether that's training or inference or batch processing of other kinds, um, that we would be really creating those bespoke value props within their environment to really not only help us to optimize product to support them, but that would also help to accelerate us to a more generally available
Hmm.
software.
So you're saying ultimately the business model would be something based on saying like, okay, um, you're running per year you're spending, I'll just call it $100,000 on. I'm sure these partners are spending more than that, but like,
Yeah,
it's just
for the sake
say a
of it.
million, $1 million on, you know, compute. And if you run our software, we're not going to charge you anything for the software per se, but you're gonna end up, you know, saving X% on that. And so we're gonna take a little percentage of your savings, and and
Correct.
and and you're gonna like keep track of that somewhere in the software and be like, have a little tally, like,
That's right.
okay, interesting. Are there other like, is there other software that kind of operates like that?
Well, like all the clouds do, right? Azure, AWS, GCP. If you're renting cloud compute, you're only paying for what you actually use.
True, but like you usually don't. I haven't usually. That's usually for hardware, you know, and
Which
so
which is very much tied to our product because
right.
we're unlocking the hardware that you already have. Um, so it's very much tied to the nodes that you're running.
Yeah, it's interesting. I
I mean,
haven't. I
the
can't think of another software that you install. It's like, oh, you're installing this software, and then I'm getting.
I think there's a lot of other customers out there. I've seen things like happen with like cloud optimization, for example, which is like performance as a service, somewhat,
Yeah,
where you
yeah,
only
and
get billed based on the outcomes. Um,
it
so
probably does exist. This is not really my world. Is I'm not like deep into infrastructure. I'm more of like a what application development type of guy.
yeah,
So maybe this totally does. And I thought maybe you'd be like, oh yeah, this is a thing, and that this is. But to me, it was new. So um, okay, that is interesting. I mean, that's a great business model to have, right? Like you just have recurring revenue. Um, and I love those business models where, because I think mine is one where, you don't have a high margin and you have a lot of customers and you provide a lot of value. And so you're in a good position where, um, you basically don't have to worry about the next month or whatever. I mean, I need to sell more licenses. I need to sell more of this or that. You just have, you get long-term customers who are happy with the value that you provide, and it's a win-win. So I hope that you can get into that mode. It's a good mode to be in.
yeah.
Um,
The other thing, I mean, is just kind of connecting the dots here with the supply demand problem that we have, right? I mean, you and I have both been doing this long enough where we saw the early days with internet and the crash that happened, and I think that we're reading lots of headlines today about are we in some type of a bubble and what is
mm-hmm.
the economic outlook that we're looking at here. Um, the big difference though between like you know late 90s 2000 was that the demand wasn't there the way that it is now. And when I think about like what you just said was like having a sticky position, so you're providing value to customers and kind of nested in creating long-term partnerships, you know
Mm-hmm.
which is ultimately where every business is trying to be. um, we just jumped off of a webinar with the CEO of a power company and they're focusing on it from a really interesting perspective. They're doing a lot of renewable energy actually. um, and I think that the future of a lot of this stuff really is baked into the efficiency matrix. Whether you're doing power more efficiently, you're running software more efficiently, you're finding efficiencies to deliver ultimately value to the end customer. And I think if everybody's looking at that, I think that we have a pretty bright future. I think right now, however, there's a lot of waste that is being identified. And I also think, like, with respect to the power piece here, which again, like, whether you choose to look for it or not, it seems to show up on my headlines every day. It's a really politicized topic, which is, more than half of the data centers that are being looked at for the next 5 years are either being delayed or canceled. So what that does is it compresses the amount of power that we will have. And
Yeah.
therefore, we need to be that much more efficient with the watts of
Yeah.
energy that we have,
Yeah. I
right?
read that article on your website that people think that it's the chips that are the bottleneck, and they kind of were. And then now that's no longer the case. It's like the utility hookups, um, permitting, that sort of thing. And so it's kind of forcing people to be more efficient and use the chips that they have, because they can't just buy more chips and put them
Yeah,
online.
that's right.
So
Yeah,
I mean,
there's backlogs. I think of, like, 18 months with a lot of these big, suppliers. They just can't keep up with the demand.
yeah, I'm drinking the Kool-Aid. I believe in it. I want to see it in action, and I want to um, I mean, I want you guys to get to market and be and have it be running and make everything more efficient. I think it's a really cool thing, man.
Thank you.
Um, As you may know, I run a vetted talent platform called Scalable Path, and I'm offering a 20% discount to listeners of the podcast. So if you're interested in scaling your dev team faster and smarter, visit scalablepath.com/commit. Like, was there anything else that you wanted to get into?
Um, I mean, I was honestly just coming to show up and go through the motions of conversation you wanted to talk about. I mean, the thing that I think is an interesting angle, worth talking about is oftentimes innovation and efficiency were at odds, I think. I think for most innovative things, like many R&D labs, many teams that are trying to invent new things, new systems, new products. I don't know what the hit rate is. Probably less than 5% ever make it to market. But I think that when we lean into the future and if we can unlock efficiency, and we look at things again through the layer cake that I described earlier, but really it's rooted in power. And if we can tackle power in an efficient manner, and then we can also think about the other pieces of the stack and maximizing the watts per bit of intelligence, if you kind of consider it tokens as that.
Mm-hmm.
I think that it's interesting because then the innovation and innovation and efficiency can kind of like cross-pollinate again, and unlock more innovation, because at the end of the day, this actually goes back to the law that you were referring to at the top of the call, which
Mm-hmm.
is if you can do this stuff more efficiently, then you can reinvest some of the savings back into R&D and innovation, and ultimately, you're gonna be helping your bottom line of the business. But if you can come up with additional things and driving top line revenue as well by innovating new things that aren't left on the cutting room floor, so to speak, it's a bright future that we have. Is
Yeah.
kind of a hopeful
I
out.
mean, yeah, I love that what you're working on could save energy, because, you know, we're in a we're in a warming planet. We've got
Yeah,
people, you know, mining Bitcoin, and I think AI, before it was like mining Bitcoin. Now it's like that's not even a thing anymore.
that's
That's
right.
like, okay, now it's AI, but it's using up tons of power. I mean, I would think that the the type of investors or people that were willing to fund you is actually broader than a regular tech startup. I would imagine that there's interest from people that are not normally, just software investors, people that are their primary goal is helping the planet, you know.
Yeah,
Have you guys tapped into that?
we have been. The we've only raised a little bit of money in the context of the really big headlines
Mm-hmm.
to date, but we're going to be raising a sizable sum in the next 30 to 45 days, and we're getting interest from the type of folks that you just described. People that are looking to not only take advantage of this massive market, but also people that want to see their dollars committed in a really impactful way that, provides future security and sovereignty, with respect to these conversations. And yeah, I think that there's some of the people that have invested to date for that very reason. But over the last 12 months, we're seeing these topics become very highly politicized. But at the end of the day, like regardless of what side people stand on, I think that we can all agree we should be eliminating waste, however and wherever we can. And if we do that, we're going to see a more thriving economy. We're going to see a more competitive landscape of innovation. It's going to allow kind of a new revolution, if you will, or a renaissance of small business builders to punch above their weight class. And it's going to allow for more innovation than we've ever seen in our lifetimes with access to these tools. So, yeah, it's a really interesting time to be building. Like no matter what level of the stack, whether you're working on applications at the top or you're working as a contractor, electrician, supporting electricity and power to the grid, we're seeing this massive influx right now that, again, like when we jumped into this a couple of years ago, we saw where the puck was going. We said, again, my two co-founders, these guys have built out some of the biggest data centers on the planet for massive hyperscalers in their background. And the three of us have collectively seen the inefficiencies that live within the stacks, and we couldn't, within our right minds, sit on the sideline and watch it happen because, again, this is a problem that's just much bigger than all of us. And to wake up and feel like, we're fighting the good fight and doing what we can and locking arms with other people that, are genuinely trying to help make this a better place for our kids and our their kids. It has to be done by eliminating the waste and the legacy thinking that's got us into this mess.
I wholeheartedly agree. I hope you guys succeed. I'll keep an eye on you guys and
Yeah, and
hope
also,
to.
I'll say I'm so sorry to cut you off, but like I felt like it sounds like you have a very technical audience here, and I feel like I probably could have done a better job by having my co-founder, join rather than me, to dive a little deeper into the technical things. And in the future, if you want to continue the conversation, I'm sure that either one of them, the CTO or the CEO, who are both very technical, can go there with you.
I'm
So
definitely open to that. Yeah, that could be really interesting. So yeah, thanks for that offer.
yeah.
Um, so that was a super interesting conversation for me. Is there anything you want, like, if you got your one shot here to just say, like, hey, this is one thing I'd love you guys to check out? Is it taholabs.com? Where do you want people to be going or checking out or looking into?
Yeah, I think check out our website, taholabs.com. You had referenced earlier, we recently published a section of our website called the Insights section. We've got two more massive tranches of research that we're about to be publishing from the last, several years of building in stealth. everything from economic impact, through the lens of a CFO, and also engineering forward documents that technical enthusiasts would likely get really nerded out over. So keep an eye out for us there. We also, this also speaks to your community maybe a little bit more so. We very much do desire to foster a developer community. We're having conversations with leading research universities, labs, divisions, around creating programs that can foster building onto our platform. We're very early in our journey, so we're not publishing this like through an amplifier yet. But quite frankly, we want to lock arms with builders, other makers and other builders that want to do their part. And if people are interested in building on TAHO, certainly there's going to be there'll be nuances on our website as we continue to move forward in that direction as well.
Great. Well, check out TAHO Labs, people. Justin, thanks for coming on, and really appreciate it. Great having you.
Yeah,
well, that's a wrap on this episode of Commit and Push. If you found it valuable, subscribe on Apple Podcasts, Spotify, or YouTube. And if you're building a team, check out scalablepath.com to find top developers. Until next time, keep building, keep pushing.